So now that we've talked about what a collector is in general and the collector API, especially for non-concurrent collectors, let's take a deeper dive into how the predefined non-concurrent collectors that come as part of the Java class library or as part of the Java developer kit, how those things are implemented. Now, keep in mind, this is what you get out of the box. So if you use Java and you use modern Java, everything I'm about to show you comes predefined as part of the Java class library. So the way this works is there's a so-called utility class called collectors, and it has a bunch of factory methods that are used to create collector implementations for common collection types. So just a quick recap on what is a utility class. A utility class is final, meaning that you can't extend it. It has only static methods. It has no non-static state, or usually has no state at all. But if it has state, it's static state, and it has a private constructor. Having a private constructor basically means that you can't make instances of the collector's class. You can only use its factory methods to make stuff. And if you want to learn a bit more about utility classes, there's a link down here at the bottom of the page that'll help you navigate through what that means. There is, inside of the collector's utility class, there's a nested class called collector impl. And you can see that collector impl is going to implement the collector interface, or rather it's going to, I guess it extends the collector interface rather. And then it provides essentially a factory for making collectors. This class is private to the JDK. It's not something you can get access to as an application developer. So it's only intended to be used internally by the Java class library implementations themselves to make the different kinds of collectors for different common collection types. So here's an example. The collectors toList factory method, which we've seen a number of times in the context of collect, uses collector impl to return a non-concurrent collector that accumulates the input elements in a stream into a new array list. And this is basically what it looks like here. If you take a look, you can see that toList, which is the factory method defined on collectors, is going to go ahead and return an instance of collector impl. And you'll see how collector impl and its constructor takes a bunch of different types. They're all functional interfaces. It'll take a supplier to indicate what the constructor reference is to make an instance of the accumulator. In this case, it's array list new, which is very common. You'll see it also takes a method reference that will be used to return the by consumer that will put the next element in the stream into the collection. In this case, that's going to be list : add. You can see it has a lambda expression that indicates what will be provided as the combiner, which will be used to combine two elements together if this was a parallel stream use of this non-concurrent collector. And then finally, it takes the characteristics, which in this particular case, we'll see in a second what it does. So here's the supplier constructor reference. Here's the accumulator method reference. Here's the combiner lambda expression, only used for parallel streams. And then finally, we have the characteristics set, which in this case is just a kind of a short static shorthand, if you will, for characteristics dot identity finish. So we're just using collector impl, or the Java class library is using collector impl internally to make these different kinds of collectors very quickly and easily. However, all this stuff that we just talked about is all private. You can't do this directly. The good news, of course, is that the designers of Java said, well, we want to give people a nice, convenient way to leverage the collector impl subclass without them having to do all the subclassing. So what they did, which is actually a very clever approach, they created an of factory method, which is part of the collector interface. And this is used to implement a collector by passing in different parameters, which of course are going to be functional interface. Functional interfaces are the types, and you can pass in method references or lambda expressions to implement those functional interfaces. So there's a couple of different variants of. This variant here is the 4-parameter version of, which takes a supplier, a by consumer, a binary operator, and optionally characteristics. The characteristics ... syntax means that the characteristics are optional. You don't have to provide them if you don't want to. And in this particular case, it's going to use the collector impl constructor that will make something that typically has identity finish. It doesn't have a finisher as part of it. Here's the 5-parameter version of, and this version of, as you can see, takes a supplier, a by consumer, a binary operator, a function for the finisher, and optional characteristics. So this is the one, of course, that's going to be used to make a collector impl that adds the finisher to the equation. So just a couple different versions. We'll see how these get used when we look at how to implement our own custom collectors in the next lesson. Both of the of versions, as you can see, use the collector impl private class. So they're using the stuff that you can't get access to, but the of interface is actually a better way to do things because it's really the factory method pattern, and it's cleaner to use. So that's the quick overview of how some of the predefined non-concurrent collectors are implemented. There's other ones besides toList. There's also toSet and toMap and so on. You're welcome to look at the Java source code if you want to see how those are implemented under the hood, but they look very, very similar to what we just saw here for the toList factory method.